All right, so let's talk about the midterm. So a few general comments first. So if you didn't do as well on the midterm as you wanted to, or if you feel like your grade was really low, right? I don't want you to panic about this, okay? I want you to panic a little about it. I don't want you to panic as in there's no way I can pass the course at this point, okay? That's absolutely not true. But what I'm seeing in the case of some of the lower grades is people doing a couple of things. In some cases, people are doing well on the programming assignments. They're doing great on the ODPs, but they had a lot of trouble with the programming on here. And there's a few reasons why that can happen. The most obvious one being that writing code on a piece of paper with a time limit is very different from programming in front of a computer, right? The time constraint is a whole factor in itself. You don't have access to resources unless they're on your note sheet. You don't have the liberty of trial and error of writing some code and saying, oh, I forgot I have to do this other thing, and so on and so forth. Be that as it may, though, the nature of these questions are set up so that hopefully if you're being successful in writing code during programming assignments and ODPs, that should translate over to here. And if it's not translating, I'm going to suggest that maybe you can change something about how you're doing the ODPs and the programming assignments. Trying to move towards where you're more likely to, the first time you write code, have it compile without syntax errors or with fewer syntax errors. And if you get a syntax error, that you don't just change it until the syntax error goes away, but that you really understand what the syntax should be and why what you typed was different from that, right? There should be no mystery when it comes to syntax in programming languages, right? Everything is rigorously defined. And if you type something that the compiler does not like, it should be possible to figure out eventually exactly why it didn't like what you put in. And while figuring that out, to figure out why you thought what you put in would be good syntax. And then it's just a matter of bringing those two in harmony with each other. That takes practice, okay, but it also takes analyzing what it is that the compiler is telling you, as opposed to, you know, changing it and the third try it compiles without an error. So that's one thing. A second thing is try to make yourself a page or two of resources that you use when you're writing your code, your programming assignments and stuff. Try to take what you need to refer to and reduce it down to a couple of pages maybe, as opposed to Google, which is not going to fit on 4 pages of notes, right? What are the things that I can never remember quite right? This business of how do you check for an integer? Oh yeah, it's %d, %s, and what is scanf supposed to return? If that's weird to you, and it is a weird thing to do, you know, try to make some notes in your own words and keep that handy and refer to it when you're working on code. And hopefully by the time you get to an exam, right, you've got a fairly refined set of notes for the things that you really need to have written down. But before the exam comes, right, if you're continually going back to this page of notes and you keep seeing the same 5 things and putting those into your code, it's going to sink in, right? And by the time the exam comes, you don't even need those 5 things to be on your page of notes, right? Maybe you need some stuff that we did more recently. Or Git syntax or something like that. But you know, a big part of this course right now is programming. The second part of it is Linux and working in a Linux environment, And by and large, actually, people did really well on that last question, which was Linux commands and Git commands, which was awesome, because usually that's where people lose all their points. And people did really well on that, so I'm inspired by that. I think people are doing a lot of work in Linux and with Git, and that's good. The programming part, like I say, it's really sort of finding this set of things that you need to have access to be able to do well when you're in a time situation and you don't have the web available. The other thing that, so I was thinking about this, if I could pin down one thing that I think helped me become a better programmer, and I think it would be this: when you find a bug, do not get rid of it until you completely understand everything about that bug. Right? Anytime that, so syntax errors are different. Syntax errors, you got to figure out the syntax, you got to fix it. If you have a program that runs, right, that program cannot be doing something wrong. It's doing what you told it to do, which means if you study its behavior, you can learn something. And if it's seg faulting, that's not a problem with the program. It's accessing a memory location that's not available, and it's saying seg fault and exiting. That's what it's supposed to do, right? So there's something you can learn there. So when you have a program that's not working correctly, when you have an ODP that's not working correctly, do not change it. Do not get rid of that bug until you understand it. Getting an ODP that runs right, okay, it gets you 100 points on one of 20 or 30 or 40 ODPs, which is 10% of your grade or something, right? It's worth a little bit point-wise. But when you write code and it doesn't do what you thought it was supposed to do, you've got to sit down, you've got to figure out what it is doing, right? And I guarantee that will make you a better programmer every time you do that. The more bugs you make, the better programmer you're going to be. But you got to go into that bug and you got to explore it and you got to analyze it and you got to say, okay, here's my code. I know it doesn't do what it's supposed to do, but what does it do? What is it doing? And if you understand that, you will understand why that doesn't do what you wanted it to do, because now you know what it does do. And then you've just got to figure out, okay, so I can't do that, so what was I supposed to do? Was I supposed to increment at the top of the loop? Was I supposed to use an AND instead of an OR in my if statement, or whatever the case might be? All right? And you got to make mistakes, right? Unless you're some kind of natural-born programmer with a genetic memory from whoever, right? You're going to make mistakes. I've been programming for 50 years almost, and I make mistakes. It's inevitable. But make sure that the mistakes are silly mistakes, right? Sometimes your brain just goes away and you just type something random, that's fine. But if it's not a silly mistake, if it's something that you really intended to write and it doesn't do what you want, you can learn from that, right? And I would say you've got to learn from that. Otherwise, you'll repeat the mistake again and again. So let me show you some solutions to these, and let me talk about things that I've saw, issues that people ran into. So question one, write a C program that asks the user for an integer. If the user enters exactly an integer, it should print the square of that, otherwise print out error. Simplest thing, first of all, it should print out the square, not the square root. I only took off a point for that. But it's supposed to print the number multiplied by itself, not the square root. That's just, reading test anxiety, test pressure, whatever. Okay, ask the user for an integer. That means, hey user, give me an integer. Okay, you're supposed to print out some kind of prompt. So that's a printf statement. So I don't know. Let's do this in code. All right, so standard io.h, I already got that. You can make your main an integer or a void. It doesn't matter as long as your return matches that. You can put in argc, argv, but you don't need them because we're asking the user for something here. So prompt the user. All right. So we're trying to get input from the user and we want it to be an integer, okay? Prompt input parse, PIP. Prompt the user if you're asked to, say, hey, give me an integer. And then you have to actually read some stuff from the user, and usually what you're going to read is a bunch of characters. And then if we want a bunch of characters, we're done. But if we really wanted an integer, we have to convert that bunch of characters into an integer. So that's what I call parse. So prompt, and then to input, for this course, anytime we want to input a bunch of characters from the user, we're going to use fgets. And it's almost always going to be the same structure, fgets, character array, length of the character array, and standard in. All right, and if we're going to use a character array named temp that holds 100 characters, we've got to define that somewhere. So we'll set that up, and I didn't see any problem with that if you got to fgets. But some people didn't use fgets. They went straight to scanf. Some people used argc, argv. That would be great if we were using command line arguments, but since we're asking the user to enter a number, we got to use fgets after we ask them that. All right, and then we have to parse. We have to convert this bunch of characters into an integer, and we did this on a number of ODPs. You got to use scanf, the string containing the stuff you want to parse, the format, and if we're being specific and we want exactly an integer and nothing else, we want to put this %s afterwards. And an address of the thing that's holding the integer, and then the name of an array that's going to hold some extra stuff. So we can do make extra 100 characters and make num an integer. Okay, %c does not work here. %c will always match the new line that fgets puts at the end, and this will always return 2 even if they just typed an integer followed by an enter key. And we've never done %s up here, but a lot of people decided, we've never done %c, but a bunch of people decided to do %c. You want to use %s here. And then we're throwing that thing that matches the %s into just a character array. And it's just a junk array, we're not going to do anything with it. And how do we know if it returned exactly an integer? If it doesn't match an integer, it'll return 0 or -1. If it matches just an integer, it'll return 1. If it matches both an integer and some extra stuff, it'll return 2. So you've got to use some kind of check on the return value. And the only reasonable way to check this is if retval equals 1, you got exactly an integer. So you can do this a few ways. You can say if it's equal to 1, then let's go ahead and print out the square of the integer. Or we could say if it's not equal to 1, let's go ahead and print out the word error. We can do it either way. Bless you. So you can do that, or you could switch it around. If retval equals 1, print out num times num and return, otherwise print error. So if you didn't do the %d, %s, I took off a few points here. I did not take it off on question 2 though, because usually if you didn't do it here, you didn't do it there either. To square a number, it's just number times number. There's no number 2 symbol. Make sure you use equal. If you were checking if ret val equals 1, make sure you use double equal, not single equal. If you say if ret val equals 1, it's going to change ret val to be 1. Make sure if you're printing out the error message, check first that you do something like a return or an else or something like that. If you don't say return, you don't say else, it may print out the error and then print out the square of number, which will probably be 0. So make sure you're doing one or the other. And make sure this extra stuff that you're reading into is just extra. It's not ampersand extra. It's not extra bracket 0 or anything like that. It's just extra, which is the address of this array, the address of the first character, which is what %s is looking for. But make sure you have the ampersand in front of num, because that's an int. All right, any questions on that? All right, so question 2, it's still a C program. Some people did this in Bash. It's got to be a C program. 2 command line arguments, so we're not asking the user for anything when the program is running. We're reading from the command line. They type program name like program, and then they type a word, and then they type a number. And it should print out that word 3 times in this case. And if you don't have 2 arguments exactly, or if you don't have an integer for the second argument, you should print out the word error. If the argument is less than or equal to 0, don't print anything, because it says print it out 0 times or -5 times or something. So you got to have argc argv here. That's the only way you can grab the arguments, or something that's an integer in a car star star. All right. If I start off with this, I'm going to risk getting a seg fault. All right. I cannot do anything with argv bracket 1 if argv bracket 1 is null. If I try to scan it, it'll seg fault. So how do I know if argv bracket 1 is null? I got to use argc. Right, same thing with argv bracket 2, even more so. Right, don't use anything from argv unless you know that it's safe to do so. And the only way you know if it's safe to use an element of argv is to check argc. So if I want to read argv bracket 2, I need argc to be at least 3. Because it's program argv bracket 1, argv bracket 2. If I'm trying to read this, I got to have at least 1, 2, 3 arguments. If I want to use argv bracket 1, I need argc to be at least 2. And if you jump into using argv without checking argc first, you might seg fault. So we want to print argv1 a total of argv2 times. So we want to use argv bracket 2. We need argc to be at least 3. And that's going to take care of this case where there's not exactly 2 arguments given. So let's dispense with that one up front. If argc is not equal to 3, that's a user error. What are we printing? Error. Alright, so print out an error and just return. And if we get past this block of code, we know that argc is exactly 3. So we have a word and we have something that should be an integer. Alright, so let's see if that thing looks like an integer. So here I saw something repeatedly. Suppose we say program hello 3. Okay, argv bracket 0 we rarely use, that's just the name of the program. Argv bracket 1 is hello, argv bracket 2 is 3. Each of these is a string. So it seems like a lot of people did something like this. Right, they tried to use scanf to parse argv to pick up this word and this number. Okay, I understand the intent. It's a good idea. It's not going to work though. For one thing, argv is not a string. It's an array of strings. Right, it's a car star star. And if it was somehow a string, it would have to contain our word followed by a space followed by the number. Then you could parse it like this. But scanf is not that smart. It's pretty smart, but it's not smart enough to take apart different elements from this array. So really you need to do two things. You need to get a hold of argv bracket 1, that's the word we want to print, and you need to look at argv bracket 2 and convert that to an integer equal to whatever it represents. So we can let's convert argv bracket 2 to an int. Alright, so I'm going to scan argv bracket 2, I'm going to try to convert it into an integer, and then I'm going to try to throw some extra stuff into an extra area. And if return value is exactly 1, then I know I had an integer with nothing else after the end. If it's bigger than 1, I had some extra stuff. If it's smaller than 1, I did not even have an integer. So if it's not exactly 1, I can just do this. Just print out an error and return. Okay, if I get to this point, argv bracket 1 is the word, num is the number of times to print this. Alright, you got to have a loop now, because we have to print out argv bracket 1, but we got to do it a bunch of times, however many times num is equal to. So there's a for loop that'll do it. You can do it with a while loop also. So So biggest issues I saw in here, one, risking a seg fault because you didn't check argc before using an element of argv. So that's one potential issue. Checking argc to see if it's something other than 3. So some people said 2 instead of 3, so that's a small error. Let me mention this one up front. So argv bracket 1 is this first word, like hello. So a lot of people did something like this. Right, they used scanf on argv bracket 1 with a %s format, presumably to convert argv bracket 1 to a string. Argv bracket 1 already is a string. Right, argv is an array of strings, so an element of argv, like argv bracket 1, is a string. And you're actually potentially damaging it, because if this string had spaces embedded in it, this would change temp to be just the stuff before the first space. So if you ran this, and now I said there were no spaces in here, but if you ran the program and you said, quote, hello space there, argv bracket 1 would be hello space there. After this, temp would just be hello.
Is there a way to tell it to use a different character as the separator?
I think there is.
Okay.
But even before you get to that point, right, there's no need to convert it to a string, because it is a string. And, you know, I said in the past, don't worry about buffer overflows on this extra piece, right? But if you were actually doing this and the argument was more than 100 characters, you're going to have a buffer overrun. And there's just no good reason for doing this. You can use argv bracket 1 as is. It's a fully bona fide string, just like temp, right? It just happens to be an element of an array, so it's got a bracket 1 after it. But this is completely legit, and it'll do exactly what you want. It'll print the value of this string. And again, the only way to know if you got a number, an integer, is to check the return value from scanf. If you try to do something like if number times 1 equals number, that's a trick we do in bash, because if number is not a number, it'll convert to a 0, and when you multiply by 1, it'll give you something weird. But if I have num, it's an integer, guaranteed, right? Num is going to be an integer. It might be the integer that corresponds to argv bracket 2, or it might be some random integer if this scanf is unable to convert an argv bracket 2 to a number. But num is always going to be an integer, because it's declared as an integer. So you really got to check the return value from scanf. All right, does that make more sense? All right, so bash code, write a bash script which asks the user to enter 3 numbers and then prints the numbers in increasing order. So ask the user for numbers. Again, you've got to print out a prompt, and then you got to do some kind of input operation, like what we would do with fgets in a C program. So in bash, the keyword is read. We can say read variable name, and it will wait for the user to type something and hit enter. Whatever they type goes into that variable. So you can say echo enter a number, and then if you say read num, you can type something, and the value of that variable will be whatever was typed. All right, you cannot get away with this. read $1. That's not going to work, and if it does work, it's not going to do what you want it to do. Read $1, hello, echo $1 is nothing. Why is that? Because $1 is nothing. So when I say read $1, I'm saying read something empty. And I can type, and it lets me type something in, but it doesn't store it anywhere. Right? Anytime you put $sign in front of a variable name, it replaces that with the value of the variable. So when you say read $1, it says read whatever this is equal to, which is usually nothing. If I had said read $0, right? $0 is equal to /bin/bash, and I can't say read /bin/bash. So if you were going to do this, what you'd really want to do is say read 1, but that's kind of silly, because you're trying to give a value to a variable that you want to call 1, and if you can change the value of 1, all bets are off. So it's not going to let you read that. It's not a valid variable name. But you don't need to read into $1, $2, $3. Those are available if we're running a script. Those are how we get the command line arguments. But you can call your variables anything that you want, as long as they're actual variable names. So same thing if you said read $num, that's not going to do what you want. It's going to read into a variable whose value is whatever, whose name is whatever the value of num is. All right, most people nailed the syntax on if statements and things like that. That was awesome. Saw a few parentheses instead of brackets, but for the most part, everybody's if statement syntax was spot on. So that's fantastic. Most people did elif instead of else if, which is good. Everybody had fees at the end of their ifs and so on. So big win on that. Most people use -le for less than or equal to, -ge and so on. A few people did less than sign, which is something different. So small deductions for those, but by and large pretty good. All right, so algorithm. So the algorithm for this was a big part of the challenge. Reading in 3 numbers and trying to print them out in sorted order. So we can read A, B, and C. And I saw a lot of different ways to do this, a few of which I had not thought of, which is really cool to see. But here's one way I was picturing it, and let me just write this in pseudocode. So if A is smaller than B and A is smaller than C, then print out A. A is the smallest of 3 numbers. And if A is the smallest, then we know we still have to print out B and C. And so we can say if B is less than C, print B and print C. Else, print C and print B. And you have to do this 3 times. So this is the case where A is the smallest number. You have to do it again if B is less than A and B is less than C. Then print B. And then print either A followed by C or C followed by A, depending on which one's bigger. And then there's a third case, which is if C is less than A and C is less than B. So that's one way with 3 main if statements, each with an if-else inside. Some people did 6 if statements. If A is less than B and B is less than C, then print out ABC. If A is less than C and C is less than B, then print out ACB. And so 6 if statements you can get there also. A few people used a loop, which was really cool. They did something like almost a bubble sort, but a simpler version of it. So they just had a loop while A is not bigger than B. Well, A is bigger than B or B is bigger than C. And then inside their loop they said if A is bigger than B, swap them. And then they said if B is bigger than C, swap those. And then if A is bigger than C, swap those. and after some number of passes, that will finish sorting, and then they just printed out ABC. And that was a clever approach. So if it looked like your algorithm was doing the right thing, and it looked like you had done at least most of the cases, I gave you credit for it. If it looked like you were missing a bunch of cases, then I took off a few points for that. If your algorithm looked pretty close, but there were a few details missing, I took off a few points for that. But I tried not to nickel and dime you on all the nitty-gritty details. For example, this will not work, for example, if A and B are equal to each other, right? I really need to say if A is less than or equal to B, and A is less than or equal to C. Otherwise, I might go through all my cases and have none of them fire. So edge cases like that, I didn't worry about marking. Bunch of people printed numbers from largest to smallest, though, and I'm not sure if that was just a misunderstanding on the question, or a habit, or just a confusion with greater than, less than. I only took off 2 points for that, but I saw that in a number of solutions, printing out the largest one first. All right, so question 4. Some people left this completely blank. And I don't know if that was a time issue because it was the 4th question, or if it was because it was kind of different from the others. So this is a bash script again, not a C program. And it should just print a table of squares and cubes. So no input, no parsing, no scanf, no arguments from the command line. You run it and it always does the same thing. It prints out 101 lines of text. So it's supposed to print out a header. I didn't take off if you didn't do the header, but most people skip the header. So print out the header, and then we need a loop, right? And I said at the beginning of class, and I wrote on the board, it's got to be a while loop, not a for loop. A few people made a for loop, but they used the word while instead of for. So that was a good try. But I want to make sure you know while syntax, because whiles are generally more useful than fors, and fors are kind of an oddball. We always use square brackets, 2 of them, in if statements and other conditions, and we use that for a while also. For fors, it changes the syntax, so I want you to learn the double bracket syntax. So we want to loop 100 times and print out n squared and n cubed. So let's start n at 1. And let's do while n is less than or equal to 100. And let's print out the value of n times n, and the value of n times itself 3 times. And then increment the value of n to go to the next value. And that should do it. Now you can use 3 echo statements. Technically you'd want to do echo dash n to say don't put out a new line at the end of the first 2. I didn't take off for that, so in some cases everything came out on a separate line. And I decided I was okay with that. In a few cases, somebody printed out the table of n, 100 lines, and then the table of n squared, 100 lines, table of n cubed, 100 lines. Took off a few points for that, but I mean, if you can do that, you can do this, right? It's just changing where you do your calculations. So that I wasn't too worried about. Missing the increment of n at the bottom or the top is a few points. That's an easy error to make. That's the one I always make when I do bash in the beginning of the quarter. And you can also do, n1 equals n, n2 equals $ per n times n, n3 equals $ n times n times n, and then you can echo n1, n2, and n3. That's fine. This is just eliminating some of those variables. Here I did care about the loop condition. If I wrote it like this and I said, well, n is less than 100, I would miss the last line of output, right? And we get to 99, it would print out 99, but it would stop after 100. Or if I started with n equals 0, it would start off with printing out 0, 0, 0. So it's doing one loop too many. So those I took off a point or two for the edge condition on. I should have tried this before class. Okay, that works. All right, so short answer, and not a lot of systematic problems on here. So let's just fill this in. So make a directory named work. That's make dir work. Change to the directory named work. That's change directory work. List the files in your present directory. That's ls, whatever your directory is. Edit a file named main, so vi main.c, or if you like nano main.c. Compile main.c to create an executable program named program, so gcc-o program main.c, or gcc main.c-o program, that works equally. Execute a program named program, that's program, or /program if you want to be sure. Delete the file, that's remove program. Rename, that's move, mv. Move main.c, program.c. I did not give you your point if you copied and then deleted main, because that's technically not renaming it or moving it. It's actually creating an entirely new file that sits somewhere different on the disk. It might have a different permission and so on and so forth. Copy is cp, so copy program.c to program.save. Make a directory named backup is the same as up there. Oh, show your working directory, print working directory. Make dir backup and then copy program.save. Backup. If you say /backup, that means backup under the root directory. That's totally different. If you say /home/myname/backup, that's going to work great as long as backup is under your home directory. But if you started this in some other directory, right, that may not be the path to backup. So just backup says look for a subdirectory in my current directory named backup. All right, git init, git add, git commit. The two commands here, git remote add origin, git at gitlab.com, username / midterm.git, and then git push origin master. And then the add and commit is again git add, git commit, and then just git push origin master. And most people got these. A few people didn't write down the syntax for the git remote add origin. That's okay. I mean, you've got it written down. Most of us just command line recall it. But most people got this, which is awesome. Okay. All right. So I left you some feedback on Canvas in some cases. Get in touch with me and we can go over your particular answers in detail and work from there. So remember, no class tomorrow. I will see you on Wednesday.
Do you have my midterm?
Yeah, it should.